Hi, in this lecture, you will learn what is a package and why we use it. Up to now, we learned types, cursors, procedures, functions, etc. And sometimes we saw that most of them do very similar things, or some of them work together. But throughout your entire work, there will be lots of functions, procedures, types, etc. because most of the times a group of team work on the same schema, and in time that schema will have hundreds or maybe thousands of functions, procedures, types, etc. So it will be hard to find something in there, or it will be hard to maintain these objects. For example, if you are using a type in only the salary calculation based subprograms, it will be cumbersome or messy to create it in the types branch, because we will not use it in so many places, but it will increase the object crowd anyway. To avoid these kind of problems, Oracle offers us to group the related plsql types, constructs, variables, and subprograms together with using the packages. With packages, we can group plsql types, variables, cursors, subprograms, exceptions, etc. in one container. So we can use these in any subprograms in the package or by another user or program, etc. We can use these objects just like we used in the previous lectures easily. But if you want someone to reach it, we will see that. This is the reason why we use packages. But actually, this is not the actual reason for using packages. This reason is the commonly known one. When you learn packages, generally you will be taught by that reason. But there is one more, but much more important reason for using packages. And this reason is known by the experts generally. Now I will show you the second, but more important reason for using packages. It's about the performance. Now you see the work logic of the Oracle database. All your functions, procedures, types, packages, etc., all your objects in your schema are stored in the storage of the database. This schema in the right represents the storage of the database. All of our objects are stored in the storage, and the left side represents the memory of the database. Now, you, as a user, all have a specific PGAs. PGA stands for Program Global Area. This memory is owned by your user and it is private for you. Other users cannot see or run any code or object in here. So some people call it as private global area because of that. Now we know that our functions or procedures are stored in the storage. There is no function or procedure in your PGA normally. But when you call a procedure or a function or type, etc., this object is loaded into your PGA first and then it is executed in there. If you call another object, it's also copied into your PGA and executed like that. So each object call will take up some space in the memory, and because of that, you may have some memory problems. Because most of the times your PGA will not have so large space. But this is not the actual reason. On the other hand, when some other user calls that object will also be loaded into that PGA too. That object may be called for hundreds or thousands of users at the same time. So this object will be loaded into all these PGAs, and this will cause maybe thousands of unnecessary memory usage. Now I will show you something interesting. Assume that we collected the objects into a package and called the object that is inside of a package. This time the usage is different. When the very first user calls an object from a package, the entire package is loaded into the SGA this time. But be aware, the entire package is loaded, and this time it is loaded into the SGA, not into the PGA. So what is the SGA then? SGA stands for the System Global Area. This is also a memory area, and this memory is shared by all of the users in the database. Because of that, some people call it as shared global area. So if it is in the SGA, how can we run that code? When the first call of a package, it is loaded into the SGA and stays there until a change occurs in the structure of that package. And when a user calls an object in that package, it is run from the SGA, not from PGA. Now, don't confuse. The memory does not run anything. The memory only keeps it. The code is run by the processor. So neither PGA nor SGA cannot run a code. So this code is taken from the SGA and run. So even if thousands of users call an object of a package, this code is loaded into only one place, SGA. So this will need so less I/O and less memory. Besides, it will improve the performance so much because there is no copy from the storage in each call. However, the variables in the package are still stored in our PGAs. So they are private for us. Even if someone changes a variable in a package, this will not affect my variable. The variables are session specific. On the other hand, the variable in the package will be a global variable and will continue living until our session ends. So once I call a variable in a package, it will exist in my PGA while our session continues living. We will see all these with many examples. Alright, now we know that the main reason for using the packages will be the second reason. Because it increases the performance, and in a real work, the performance will be so important for you. So what are the advantages of using packages? We can group logically related objects. So we can find and share our objects in the packages much easier. Since all the objects are related to each other, we can easily understand, modify, and maintain the objects in it. We can have public or private objects in our packages. Only the objects declared in the package specs are visible or reachable to the others. The other objects declared in the package body cannot be seen or run by another user or application. So we can easily encapsulate our objects. Besides, we can encrypt our package body, so no one else can see the code in your package. These are really useful benefits of using packages. The entire package is loaded into the memory when it is first called. So no need to copy the same code into the memory for all the users. So this will improve the performance pretty much. Because I/O is a really costly operation. We will see the persistency of public variables and cursors in packages. So we will learn how to create a living variable or a cursor in entire session. This is also a useful functionality. We will see how to do that. We saw how to overload the subprograms before. Actually, we don't overload a stored subprogram most of the times. However, in packages, we frequently need to overload the subprograms. And overloading the subprograms in packages is easier, faster, and more beneficial. Alright, to sum up, packages are the containers that can have functions, procedures, types, variables, constants, exceptions, cursors, and pragmas. So we can easily share these objects between the package objects, and we can share the public variables with the others. Besides, we will have a great performance gain with the packages if the related object is used by several users. So using packages are pretty efficient, and we will see how to create the packages in our next lecture. Alright, this is the end of this lecture. See you in the next lectures.